So Rocky had an awesome question, but I don't know how to answer it by typing it on the discussion board, so I thought I'd answer it in a video. Also, Sean mentioned that he wanted to see videos, or was mentioning it, so if you guys come up with questions or something that you don't understand, I could do a video response to it, and maybe it'll help you understand it. Looking at Rocky's question here, I guess it's number 25 in problem set 5. It says find du dv if u equals y to the third power, y equals x over x plus 8, and x equals v squared. And some of you, I'm hoping all of you, probably had some sort of question on it, and nothing against Mabel, but, or I guess who else said that? Maybe Benny, that if you don't have any questions, then maybe you need to go over it a little bit. My old teacher used to say, if you don't have any questions, then you probably didn't read it, which is probably true. So let me answer Rocky's question, and let me rewrite it. I'm going to open up a notebook app here. And she said, let me hide this real quick. She said, the question asks, find du dv, oops, find du dv, this is terrible, find du dv, and what that means is find the derivative of u, okay, with respect to v. So what we've been seeing so far, or the only types of derivatives we've been doing is dy dx, which means find the derivative of y with respect to x, or find the derivative of a y equals function that has x's in it. This one says find the derivative of u that has v's in it. What Rocky found, or what Rocky's example says, is that u, let me go back and forth here, u is y to the third, y is x over x plus 8, and x is v squared. Let me just double check if that's right. Yeah. So if I want to find du dv, okay, the problem is that when I do the derivative of u, it's in terms of y, which is not what I want to do. I want the derivative of u in terms of v, but this one is in terms, this one right here is in terms of y. So, but y can be converted into x's, but that's not right either because I want this in terms of v. But the last thing they gave us is that x can be converted into v's. So let's do this step by step. First of all, I want the derivative of u. So this right here means take the derivative of u with respect to v. So what I'm going to do, instead of y, I'll plug in the x's. So u, instead of saying to the y to the third power, is the same thing as x plus 8 to the third power. Okay. But again, this doesn't work because I want the derivative of u with respect to v. This is u. There's no more y's, but now they're x's. But I don't want x's, I want v's. The third piece that they gave us v's, so I'm going to convert all my x's into v squareds. And now I can take the derivative of du dv, or I can take the derivative of du dv, because now I have a u function, and I have only v's in the problem. Now I can take its derivative. Someone in the discussion boards, I forgot who had said it was, but I think a lot of you have this problem. It's like, which one do I do? Chain rule, quotient rule, product rule, power, what do I do? And the best thing is think of it as order of operations. You have to do the outside function first. So you see how this is a parentheses to the third power? That's a derivative I have to take first. Even though I have a quotient or division on the inside, I have to do this one on the outside first. So let me see if I have enough space here. The derivative, or du dv, the derivative, is equal to, and I have to do chain rule out in front. So would you guys understand if I did this? So chain rule, I put the 3 out in front, leave the inside alone and raise it to the second power, so it's power rule on the outside, times the derivative of the inside. Oops. Times the derivative of the inside. So that means I have to take the derivative of the inside, and the derivative of the inside is quotient rule. Which means take the derivative of the first one, leave the second one alone, minus, leave the first one alone, and then denominator, all over the denominator squared. And that is how you take the derivative, that's how you take du dv of that problem. And I know it's not a very pretty answer, but it is the answer. Oops. So hopefully that explains it. I'm going to make another one for Leslie real quick, but I hope you understand it. Hopefully it's not Rocky watching this. hopefully somebody is watching this, and I hope you understand it.